Okay, good day, good people. Let us look at how to calculate the moment of inertia. If we are given the square bar, because the sides of a square, they are equal. Now your ixx equals to your iyy. Now in calculating your moment of inertia, if this is where you have taken moment, this is where you have taken moment, you are opposite to, this would be the breadth of the beam, this would be the depth of the beam. Now it will be bd cube divided by 12. This is the formula that we'll be using to calculate what? The moment of inertia. Now when we are dealing with the round bars, solid bar, your ixx equals to your iyy. Now in calculating the moment of inertia, it will be pi multiplied by d quad divided by 64. Why? The radius, it is the same. From here to there, radius is the same. It is d divided by 2, whereas center going up, d divided by 2. It is the same as your square. Now when you are dealing with the hollow shaft, you then have to consider the inner diameter and the outer diameter. Now in calculating the moment of inertia, it will be ixx equals to iyy. They are the same explanation as the square, solid bars and all that. Now it will be pi divided by 64 open bracket, the big D minus the inner diameter, then you get the value of your ixx, right? Then you get the value of your ixx or your iyy. Now here on these three bars, your ixx, it is the same. Now this bar, it doesn't have the weakness, it doesn't have the weak side and the strong side. All sides are the same. All right, on these three bars, all sides are the same. All right, then when you are dealing with the rectangle, please be aware of the position of the rectangle. Now if this is where I'm taking moment in calculating the ixx, this would be my b, this would be my d. Now I've taken moment at y-axis, y-axis, this is y, this is x. If I've taken moment at x-axis, then I'm determining for ixx, then it will be opposite. If I've taken moment at ixx, my ixx, it is opposite to b, then it will be b, then d cube divided by 12. If I've taken moment at y, if this is where I've taken moment at y, I'm obviously determining for iyy. If this is where I've taken moment, I'm opposite to d, then you will start with the value of d, then you will cube b. You will put b at cube, then it will be d multiplied by b cube divided by 12. Then you would have determined that the iyy, and if you have taken moment here, you would be determining what the ixx. Now the ixx, it is the strong side of your beam. The ixx, it is the strong side of your beam because it is the short side. In most cases, you can tell that from there to there, it is the short side, comparing to there to there, it is what? The long side. Now the iyy, it is the weak side of your beam, right? Now whenever you are given statements in calculating whatever that they want you to calculate, be it the moment of inertia, be it the bending moment and whatsoever, always put your beam on the strongest side. Apply your beam on the strongest side. I like applying the force on the weak side. Obviously this beam, it is on its weak side, obviously the beam will bend. But if given statement, always put your beam on the strong side. Always put it on the strong side when you are dealing with it. You will see now when we are doing the application. Now like I'm saying, the position of your beam, it is important. Now if you are given the beam now in this way, in this manner, right, you can tell this is your y, it is the longest side, then this would be your x, it is the shortest side. Now if this is where I've taken moment, I'm opposite to what? If I've taken moment at y, I'm opposite to what? To the longest side. That means here it will be I x x. If I'm determining the I x x, then it will be d b cubed divided by 12. Why? Because where I've taken moment, I'm opposite to y. And if I'm taking moment here, it will be y equals to b d cubed divided by 12. Where I've taken moment, I'm opposite to what? To b. Now, in this manner, you can tell that as your beam, it's been rotated or it's in a different position. The IYY, it is the strongest side. The IXX, it is the shortest side. Like I said, the strong side of the beam is always the short side. In this case, this is where I've taken moment at IYY, but the shortest side, it is that IYY. From there to there, it is the shortest side. It means in this position, our IYY is the smallest side. Please, the position of your beam, it is important. Now let's do the application on how to calculate the IXX and the IYY. Now let's look at this given examples here in our books. A rectangular beam having sides, this is what I was referring to. If you are given statements, beams in words, you must always put it on its strongest side, meaning when you are projecting the given information into a schematic, this is how you will write it. The longest side, it is 160, then the shortest side, it is 100. You have placed your beam in its what? Strongest side. Then you can apply the force on the beam. Unlike if you've projected your beam in this manner, in interpreting the given information and the applied force, you'd realize that this force, this beam, it will break easily. So comparing to this position here, is loaded with the longest side vertical. That's what they are indicating to us. Calculate the magnitude of the point load which can be applied to the middle of the beam. Now here they want us to calculate W, but I'm not interested in calculating W. Anyway, in calculating W, we then have to apply this formula. IXX equals to stress over Y. We are looking for W. Where are we going to calculate the W? We have to use bending moment to calculate W. Now we then have to determine if it's a simple beam, simply supported beam, or if it's a beam that has uniformly distributed load. Calculate the magnitude of the point load which can be applied to the middle of the beam if it is simply supported at its ends. Now we are told, now in calculating the bending moment, it will be bending moment. It's a simple beam that doesn't have what? Uniformly distributed load. Now it will be W multiplied by L over 4. It's a simply supported beam. Now that means in calculating the W, then we have to make the W the subject of the formula. It will be M4 divided by L. Do we have L? Yes, there it is. It is given as 6 meters. We then have to calculate for M. In calculating for M, we then have to determine moment of inertia because it is not given. Stress, it is given. There it is 180 megapascal. But I'm not interested in solving the whole thing. I'm interested in showing you how to calculate the moment of inertia. The Y, the centroid, it is given. Remember I once said to you, if necessary, calculate, meaning use the area moment to calculate what the centroid. But in this case, there's no need for us to use the area moment. We are given 160, the longest side. Then it will be 160 divided by 2, not 20. It will be 160 divided by, then we get our answer as 80. That means our centroid there, it is what? It is 80. We have calculated our centroid there. But I'm not interested in that. I'm interested in this because we need to use a bending moment for us to be able to calculate the force that they are looking for. But I'm interested in showing you how to calculate the moment of inertia. We have the stress, we have the centroid, we need to make this the subject of the formula, then we need to calculate that. Now in calculating the moment, you are always working. Remember, on this formula, this is your maximum bending moment, max. It is your max. The IXX, it is as well the max, meaning it is IXX. the moment of inertia, you must always work with the strongest side there. Equals to stress, it is always max. Why? It is always max. Yeah? Not unless they've stated otherwise. If they've stated otherwise, it means this side you will have stress mean over y mean. Then this side it will be obviously max because we are at the critical point. Then here it will be ixx. Not unless they've stated otherwise on the given information, then we can apply this here. But if not, then we must always work with what? With the maximum. Right, now in calculating the moment of inertia, we will take moment here. Remember, we are on the x-axis. This is our x, this is our y. All right, we will take moment where at x-axis. Yeah? Now, if we have taken moment at x-axis, we are determining for ixx. It will be, we are opposite. This is where we have taken moment. We are opposite to what? To 100, of which it will be our b. Then multiply by d cubed divided by 12. Then it will be our b, it is 100, multiply by 160 cube divided by 12. Then we get our answer as well. Now, always convert your values to meters. Convert them to meters. I'm just showing you in working them out in just calculating. Right. Always use the millimeters. Okay. Then we get our answer here. We get our answer as 3,413. 10 times to the power negative 5 m quad. Right. This is how you calculate your moment of inertia. Right. Let's look at the second question there. Let's look at the second question. Let's look at the second question and apply how to calculate the moment of inertia. Right, the moment of inertia. All right, let's look at the second one. Or let's re-emphasize the first one. Let's re-emphasize the first one because it was clustered. We are having 160, we are having 100. Then let's convert them to meters. It will be 0.1. Then this one, it will be 0.16, okay? Then we are calculating for ixx. Remember I said it that in this formula, you must work with what? Ixx. Now it will be ixx, meaning this is where we have taken moment on the x-axis. Right, equals to b d quad cube divided by 12. Then our b, it is 100. When you divide by 1000, it will give us 0.1. Then here when you divide by 1000, it will give you 0.16. Then it will be 0.1 multiplied by 0.16 cube divided by 12. Then our answer will be 3,413 10 times to the power negative 5 m quad. Right, this is how you calculate your moment of inertia. Right, now let's look at the second one. The second one, we are dealing with something which is round. Now we then have to determine if it is the hollow or solid. A cylindrical beam 6 meter long with diameter. Now here diameters, it means we are dealing with the hollow shaft. Right, we are having the D out, it is 200. D out, it is 200. Then it will be 0.2 meters. Then the D in, it is given as 100, 0.1 meters. It's simply supported at its end. If the maximum stress, like I said, we are given the stress, calculate the magnitude of the uniformly distributed load. Now they want us to calculate, but I'm not interested in that. I'm interested in showing you how to calculate the moment of inertia. It will be Ixx equals to Iy, because it's a round cylinder. Okay, now I'm having pi divided by 64, open bracket, big D squared minus small d, right? This is the formula that we need to use. It is pi 64. Our big D, it is 0, 0,2 quad minus 0.1 quad divided by, oh, there's no division there. There's no division there. Let's write it nicely. Right. Open bracket, it is 0.2 quad minus 0.1 quad. Then we get our answer as 0.2 quad minus 0.1. We get our answer. As I punch my calculator, I get my moment of inertia 7,249, 10 times to the power negative 5 m quad. Now this is how we calculate the moment of inertia for a rectangle and round bars. Now this is the application of how to calculate the moment of inertia. Then I can go ahead and do the application in terms of solving few activities in our books. I will drop videos regarding that. Thank you, good people.